class, let's talk about the law of sines. Glad that you were able to find my video. I know that things are a little bit different doing it this way, but I think you actually might end up liking it. So I'm actually teaching the lesson right now in my pajamas, but you guys don't know that. Haha. So law of sines. We've done a lot of trigonometry, but so far all the trigonometry we've done, it's only been involving right triangles. Like sine is ratio of opposite to hypotenuse, cosine is adjacent to hypotenuse, tangent opposite to adjacent. Only though if we're talking about right triangles. So like a lot of times though, things aren't really right triangles. How can I solve for sines or angles of non-right triangles? So we're still going to use some trigonometry to help us come up with how to solve these oblique triangles. So draw a scalene triangle on your picture or on your notes. By the way, you guys need to be stopping this video all the time and be writing down the pictures, writing down the notes. Okay, keep stopping. You can rewind, all that good stuff, because you can't miss any of this. But I'm not going to pause in the video for you to write it down, so you're going to have to hit the pause button yourself. Okay, so on your picture, on your paper, you have a scalene triangle, and I want you to draw one of the altitudes. Remember, an altitude has to come from a corner of a triangle and go perpendicular to its opposite side. Okay, so you've got an altitude drawn on your picture. I labeled the angles A, B, and C, and then their opposite sides, side A, side B, side C. And then I called the altitude H. So you might want to do the same so that way our letters are matching each other. So we now have, even though this is a non-right triangle here, it's a scalene triangle, I can still look at this like two separate scalene triangles, or two separate right triangles rather. So if I look at this one, I'm going to highlight that one in blue, and that's one right triangle, and then I have a different right triangle over here that I'm highlighting in green. So if I look at the green side, okay, well, since that's a right triangle, I can use that sine is a ratio of opposite hypotenuse. I can use those ratio of sides that we learned in the last unit. So let's look at, well, how would I figure out like how big angle H, or not angle H, but this side H is here. Let's try and use the green right triangle to help us figure out how big that side is. Well, I mean, I could use this angle up here, but I might as well, but what would I call that angle? I guess angle CA something. So let's instead use this angle C over here and try and relate this side over here. So if I use if I have this opposite side, and maybe I won't use this adjacent side here. Maybe I'll use this hypotenuse side, because I'd really like to use sides that were on the original triangle rather than on parts of the original triangle. So if I use the opposite and the hypotenuse, then that means I need to use the sine function. So if I take the sine of angle C, that would be this H side divided by the hypotenuse would be B. Okay, so opposite divided by hypotenuse. And let's do the same thing for the blue triangle. Okay, on that blue right triangle, let's try and come up with a way of relating this H side again. Well, let's see here. I could again let's use angle B, because that's on our original triangle, on our scalene triangle. So sine of angle B would be that opposite side divided by its hypotenuse. So both of these equations I've just written down now have this H side in it. So if I multiply both sides here by side C, then I have that H is equal to side C times the sine of angle B. And on my other one, if I multiply both sides by side B there, then I've got B times the sine of angle C is also equal to that altitude, which I called H. Well, this one is equal to H, and this one's equal to H, so I can set those two equal to each other. So I've got C times the sine of angle B is equal to B times the sine of angle C. Okay, just did some substitution there with H. Well, think about like if this was some kind of a proportion. If it was a proportion, like I multiplied C and sine B together. So I could have sine of B here, and I multiplied it by C, so that way when I, ignore that, hit a button. So that way when I cross multiply them, I do get C sine B. And for the other two, I multiplied side B with sine B. side B with sine of, I think I said B. I meant to say C there. So now I've got a proportion. This is the development here of the law of sines. That even though this was not a right triangle to start with, I can use this law of sines to help. This is the derivation of the law of sines. I can use this law to help me figure out how big angles are, how big sides are on a non-right triangle. So the sine of this angle B divided by its opposite side is the exact same as the sine of angle C divided by its opposite side. And this is actually true for sine of angle A as well, that the sine of angle A divided by its opposite side is the same ratio as these other ones. So I can add in here sine of angle A divided by its opposite side. So that's called the law of sines. So there it is. Sine of A over side A is the exact same ratio as sine of angle B over its opposite side is the exact same ratio as sine of angle C over its opposite side. So we can use the law of sines to find any missing sides or angles, for that matter, of any triangle that we encounter. And that does include right triangles as well. It's just probably not as easy to use this law of sines for right triangles, but you could, but it'd probably just be easier to relate the sides and angles by using opposite to hypotenuse as sine and adjacent to hypotenuse as cosine, using the sine, cosine, and trig functions we talked about last unit. Okay, so let's try to do an example with the law of sines. Let's see. So go ahead and put down this triangle on your paper, and let's solve for angles B, angle C, and side B. Well, I'm only seeing one angle here that I have. This is degrees, by the way. So I have 104 degrees. So let's solve for one of these missing angles. I probably don't want to choose angle B. I'm not going to solve for that angle first, because if I do that, then it's going to look like this. Don't write this down, but this is what would happen. Oh, sine of angle B divided by its unknown side B is equal to, oh, wait a minute. Now I have two variables, angle B and side B. I don't know either one. So I'm not going to use angle B, and I'm not going to use side B. So let's choose something else. Let's solve for, well, angle C has its opposite side there, so maybe I want to relate those two and help me solve for angle C. And angle A, I've already got its angle and its opposite side, so that's very convenient. So I'm going to do the sine of angle C divided by its opposite side is equal to the sine of angle A, which we know is 104 degrees, divided by its opposite side of 28. If you don't have your calculators out right now, get it out right now. You're going to want to practice typing this in your calculator. There's a lot of mistakes that you could mistype something in your calculator, not store it correctly, that you could lose some points on a test or a quiz. So make sure, first of all, that your calculator is in degree mode. And if I start solving for C first, though, here. So if I multiply both sides by 17, then I'm left with sine of angle C is equal to 17 times the sine of 104 divided by 28. So let's go ahead and type that into our calculator right now. So type in 17 sine, and I already checked, I am in degree mode, of 104, close your parenthesis, divided by 28, enter. Okay, long decimal, but remember that's what the sine is equal to. Just so later on you can see what we did. Sine of angle C equals 0.589, and then there's a lot more numbers after that, but we're just going to start with that number so it's on our paper. And now, how do I get rid of sine, right? You have to take the arc sine. You got to take the inverse of sine. So arc sine, both sides, and then I'll have C equals whatever that number is. So if I take the arc sine, so second sine of that answer, so it's got to be this exact number, okay? Now, if you need to write out all those decimals, that's fine. But I can just, if you have a graphing calculator, if you just hit second and then the negative button, it says answer right there. It'll automatically take that previous answer and put it right there for you. So it's about 36.1 degrees. So that's good enough. So about 60 or 36.1 degrees. Now, right now, before I forget, I want to store that number. So I'm going to need to use that angle a little bit later on. So I'm going to hit the STO button right above the on button, and I'm going to store that as angle C. I'm putting it in as letter C because it was angle C, and then that'll be easy for me to remember. So I'm going to hit alpha and then my letter C, and then hit enter. And now later on when I want to use angle C, it'll have that number exactly for me stored. Alrighty, now what are we doing? Oh, we figured out what angle C was. It was about 36.1 degrees. And now we need to figure out how big, well, what else could we figure out? It'd be pretty easy at this point to figure out how big angle B is, I think. I know a triangle has to add to 180. So if I do 104 plus angle C, so plus, and it's already got angle C right there for me. Either I can hit alpha C, or I could go up here and I could grab it and it'll, oops, no, I don't want all that, but it'll grab it for me as well. Okay, so what are we doing again? Oh yeah, 180 minus angle C, oops, angle C plus angle, what was angle A again? 104, 104. And that must be angle B, about 39.9. I'm going to go ahead and store that while I'm thinking of it as angle B. Enter. So about 39.9 for angle B. Notice I'm using capital letters for the angles, and for the sides I am using lowercase letters. Please do the exact same. Have we solved for everything? No, we have not solved for a side B. Okay, so for side B, you notice that the law of sines, so if you think about the number 1/2, let me just this is like my scratch paper over here. So the number 1/2 is the exact same as 2/4, is the exact same as 4/8, right? Those are all the same as 1/2. But I can take the reciprocal of all those. So 2/1 is the same number as 4/2, is the exact same number as 4/8. I can do the same thing with the law of sines, that not only is this true, but their reciprocals are true. So A over sine of angle A is the same ratio as B over the sine of angle B, is the same ratio as C over the sine of angle C. Okay, so I'm going to use a reciprocal, so that way B is on the numerator this time. So B divided by the sine of angle B, which was approximately 39.9, but we're going to use our stored number in our calculator so that way we keep our answers exact to the very, very end, has to equal, now I could use sine of angle C divided by 17 if I wanted to, but I'd rather just use angle A. It looks like an easier number for me to have to work with, and I don't have that number stored in my calculator. So side A, 28 divided by the sine of angle A, sine of 104. And then if I multiply both sides by sine of 39.9, that should tell me how big B is. So back to our handy dandy calculator, 28 divided by the sine of 104, close my parenthesis, times the sine of angle B. So, and I have angle B stored as alpha B. Now I want that exact number. It's about 18.5. So side B is 18.5. Okay, all of our answers are exact to the very, very end here. So when can we use the law of sines? Well, the law of sines happen basically when you've got an angle and an opposite side matched up. Like I had this angle A and its opposite side 28. Therefore, since I had angle A and side A, I could use the law of sines then, and I could come up with a ratio. So that'll happen basically when you have two angles, or you could have one angle as long as you have its opposite side. Now we're going to talk about this angle big side, little side tomorrow when we, or in the next lesson when we do the ambiguous case. But for right now, I'm not going to give you anything where it's going to be that special case that we're going to learn tomorrow. So if you have these situations, it's going to be the law of sines. I don't memorize that. I just remember, do I have an angle and its opposite side paired up together? Okay, well then I can just use the law of sines. If not, then you're going to use what we call the law of cosines, which again we'll learn in a couple of days. But that's when I have three sides. Well, law of sines isn't going to work if I have three sides because I don't have an angle to match up with its opposite side. Or a side included angle in a side. If I know this side and this angle and this side, again, I don't have an angle and its opposite side matched up. So thus the law of sines is not going to work. We'll have to use something else called the law of cosines. Again, that's for a later lesson. So again, these laws are for oblique triangles. SOHCAHTOA, that does not work on oblique triangles. You don't have a hypotenuse when you're talking about an oblique triangle. So this is the first part. You guys can go ahead and then click on the part 2 video. So look for the Trig Day 8 part 2 video.